Hello amazing learner, welcome back to the Zoom Chemistry Hub. Today in this video we will learn all the important formulas from the chapter acid, base and salt with simple definitions, formulas, examples and trick, and it is perfect for Olympiad and all the competitive exam. First, pH formula. We can define the pH as pH tells how acidic a solution is. Formula: pH is equal to negative log of hydrogen concentration. Example: if we have hydrogen ion concentrations are 1 into 10 raised to power minus 3, then the pH is equal to the negative log of hydrogen ion concentration. So we will put the value of hydrogen ion in this formula after calculating the negative log of hydrogen ion concentration and putting the value, we will get the pH value is 3. Smaller the pH means stronger the acid, and if hydrogen ion is 10 raised to power minus 3, then the pH is 3. So it is the acidic solution. Next, hydrogen ion formula. It gives the concentration of hydrogen ion in solution. Formula for hydrogen ion: the hydrogen ion is equal to 10 raised to power minus pH. Example: if we have a pH 5, then what will be the hydrogen ion concentration of this solution? So we write the formula that hydrogen ion concentration is equal to 10 raised to power minus pH, and we will write it as that the value of pH here is 5. So we write concentration of hydrogen ion is equal to 10 raised to power minus 5. To get the hydrogen ion, just take 10 to the power minus pH. Next, pOH formula. It shows how basic a solution is. Formula: the pOH is equal to the negative log of hydroxide ion concentration. Example: if we have hydroxide ion concentrations are 10 raised to power minus 4, then we will write the formula first, that is pOH is equal to the negative log of hydroxide ion concentration, and we will put the value of hydroxide ion concentration in this formula. So we will get the value of pOH is equal to 4. Next, hydroxide ion formula. Hydroxide ion is equal to the 10 raised to power minus pOH. Example: if we have a question in which the pOH value is 3, then what is the OH value? So we will write the formula as that is the hydroxide ion concentration is equal to the 10 raised to power minus pOH. We put the value of pOH in this equation. So we will get the hydroxide ion concentration as 10 raised to power minus 3. Next, we have a formula that is pH plus pOH is equal to 14, and this is always true at 25 degrees centigrade. Examples: if pH is equal to 5, then pOH is equal to 14 minus 5, that will be the 9. Remember this golden rules that pH plus pOH is equal to 14 at the room temperature. Next, we have Kw, that is the water ionization constant or the dissociation constant of water. Kw is the product of hydrogen ion concentration and hydroxide ion concentration in the pure water. Formula for Kw is equal to the concentration of hydrogen ion into the concentration of hydroxide ion, and that will be equal to 1 into 10 raised to power minus 14 at 25 degrees centigrade. Examples: if hydrogen ion concentrations are 10 raised to power minus 6, then the hydroxide ion concentration will be the 10 raised to power minus 14 divided by the 10 raised to power minus 6, and we will get the value of hydroxide ion concentration is 10 raised to power minus 8. Use Kw to find the missing hydrogen ion or hydroxide ion. They always multiply to the 10 raised to power minus 14. Next is the Ka, that is the acid dissociation constant. It tells the strength of an acid. For example, if we have an acid and it will dissociate into their ions, that is an acid Ha, and it will ionize into hydrogen ion and A minus. So we will write the formula for Ka is equal to, it is the ratio of the product of the concentration of the ionizable ion divided by the acid. So we will write it as that Ka is equal to the concentration of positive ion into the concentration of negative ion divided by the concentration of acid. Higher the Ka means stronger the acid. It shows how much the acid ionizes. Next is the Kb, that is the base dissociation constant. It tells how strong a base is. Formula: if we have a base and when it will ionize into their ions, so we write it as, that is the Kb is the dissociation constant of base is equal to the ionizable ion divided by the concentration of. Next we have pKa and pKb formula. The pKa is equal to the negative log of dissociation constant of acid, and pKb is equal to the negative log of dissociation constant of a base. For example, if Ka is equal to 10 raised to power minus 5, then the pKa value is 5. Smaller the pKa means stronger the acid, and same for the pKb and base. Next is the pKa plus pKb is equal to 14. This is valid at 25 degrees centigrade. Examples: if pKa value is 4.5, what will be the pKb value? We know that pKa and pKb is equal to 14, and if we have pKa value 4.5, then we will calculate the pKb value as, that is the pKb is equal to 14 minus 4.5, that is 9.5. This helps you to find the pKb. If you know the pKa, just subtract from 14. Next, Ka into Kb is equal to Kw. Formula: the dissociation constant of acid into the dissociation constant of a base is equal to 10 raised to power minus 14. Ka and Kb always multiply to Kw. So that's for all together, learner. Don't forget to like, subscribe and share this video. Thanks for watching.